Okay, in this video, we're going to talk about finding the conjugate acid and finding the conjugate base. Not to overwhelm you with too much vocabulary, but there are a couple main words that you need to know. The word conjugate means related, and that in chemistry means that you're always adding or subtracting a hydrogen. To find the conjugate of something, all you have to do is add or subtract a hydrogen. If something is polyprotic, the prefix poly means many, protic refers to protons. So if something contains more than one hydrogen, which is also known as a proton, we call it polyprotic. A base accepts hydrogens or accepts protons. An acid donates hydrogens or donates protons. If something is amphoteric, that means it can be an acid or a base. Amphoteric always refers to something that's polyprotic. Okay, before we get any further into that, I want to explain what I mean when I say find the conjugate acid and find the conjugate base. To find the conjugate base of something, if HF is acting as an acid, in this case it's going to turn into F-. Remember, it's a base that can accept hydrogens. HF really can't accept any hydrogens in the position that it's in. F- can accept hydrogens. So in that case, that would make this the acid and this the base. To find the conjugate base, all you have to do is take away one hydrogen. When you take that hydrogen away, you also need to think about how is the charge affected. So in this case, H3PO4, this is a neutral molecule right now. So when I remove a hydrogen, and remember, even though this is polyprotic, we're only going to remove one hydrogen from it. This is going to become H2PO4. But I took away one of those particles that was positively charged. So that means that this is now going to have a negative charge. On the other hand, if I start out with something that has a positive charge, like H3O positive, and I try to find the conjugate base of that by taking away a hydrogen, if I take away one of these hydrogens, that gives me H2O. I'm actually not going to make this negative because it was already positive to begin with. So if something has a positive one charge and you take away one positive molecule, you end up with something that's neutral. And then for our very last polyprotic molecule, this is a larger molecule, but we're going to do the same thing. You take away one hydrogen. So this is going to be HClO4. And then we're not going to put a charge on it because it was already positive. So when you remove one positive particle from that, it's now going to be neutral. Okay, to find the conjugate acid of something, all you have to do is add one hydrogen. So Br becomes HBr. Now, unlike with our polyatomic acids that we were talking about earlier, we're not necessarily adding the right number of hydrogens to neutralize the charge. All we're doing is adding a hydrogen. Remember, when we're doing conjugates, we're only adding one hydrogen or removing one hydrogen. We're never taking them all away or adding as many as we need necessarily. So HSO4 negative becomes H2SO4, and CO3 2 negative. Remember, it's important here to know the difference between a superscript and a subscript. 2 negative is the charge on this. That 3 refers to the number of oxygens. So CO3 2 negative will become HCO3 negative. Remember, 2 negative, that charge only goes up by 1. So if you were looking at a number line and you increase -2 by 1, it would bring you to -1. So that's what this charge is. We're not going to add 2 hydrogens to this to neutralize the charge because we are dealing with conjugates. Conjugates always only add or remove one hydrogen at a time.